everybody. All right, so I'm going to do the run through of how we use our melting stations, and the one I'm choosing to use is the Vernier system, mainly because it's going to film a little bit better. But I got too much here. Has a little dial on the front that you will use to set the temperature, and they're actually relatively accurate on these. So since we're looking at various different things, you can almost dial this to what temperature you think the melting point is. And today we're going to know because we're giving you ones that are known. And you will be looking right through this lens, and you're going to be looking at that little steel block that's in there. And that's where the samples will go. And on this, I just have it hooked up to one of the little LabQuests. But you could have actually got out one of the computers too. But I just have it on the LabQuest. Now, we'll show that here in a bit, but what we're going to do now is show you how to prepare a sample. Now, the two things that I'm going to be running today is salicylic acid, precursor to aspirin, and then just standard old table sugar. Now, I chose these on purpose. Typically, I get a very nice melting point with salicylic acid, or melting range, because we're going to figure out what that actual range is. I don't expect it to be great this time, though. You can't see it in the video, but we've had some leaks in the lab, and the stock room was quite wet, so all the chemicals, well, they're not wet, but they got moist from the humidity in there when it was drying. So I don't think we're going to have a great range on either one of these. I think all of them got a little bit of too much moisture in them, and I didn't bother to dry it. I mean, all I would have to do is take the samples and throw them in the oven and dry it, and it'll come out better. That would definitely work with salicylic acid. The sucrose would probably break down on me, though. All right, so what I did is I just took a small sample of each, put them onto like a watch glass. This is way more than I actually need for the melting point, but it's a great example of how we would do this if we're doing the actual lab with all the students in here, because that's probably about how much I'd put on there, and then everybody would take some. All right, so when we get a melting point, we're going to actually put our solids in a melting point capillary. Now, these just say capillary tubes, but some of them actually do say melting point on there. So all I'm going to do is the open end, I'm going to tap in the solid. And maybe about 5 millimeters deep. So not very much. And now the trick is I want to get it down to the other end. Now theoretically you could do this forever and it would go down. But what I did was I grabbed a burette, pulled the end of it off, and now I can actually drop my capillary. And we just do this repeatedly to get that packed in as tight as possible. The more you do this, kind of the better, because the tighter it is packed, it's going to help your melting range. Since melting point is related to how well the crystal packs, we're kind of forcing it to get closer by doing this. And I'm going to just go ahead and stop the video, but I'm going to do this more. I do want it packed in there kind of tight, but more importantly, I might need to add some more to this one. I want to be able to put it down over here, and I want to be able to see the top of the solid, but I'd like to have this a little bit more full. And I think I'm going to put some more into this capillary and tap it a little bit more, because I do want about 5 millimeters deep at least. And then I'm going to do the same thing with the sucrose. I'm going to pack it even more than I did the sucrose because, or the salicylic acid. The sucrose, being a larger crystal, is going to space itself out more. So packing it will help us out tremendously. So I'm going to finish that up, and then I'm going to move the camera so we can see the melting point apparatus.